Hello, learners. Welcome back to the course Mastering in Computer Graphics from Pixel to Virtual Worlds. So, we are in the module 4. In the last session, we studied scanline method, depth sorting method, and BSP tree method. So, in this session, we'll be discussing area subdivision method, octree method, and raycasting method. So, these methods are widely used in computer graphics for efficient determining the surfaces which is visible to the viewer or not. So let's start. The first method is area subdivision method. So this method is based on the divide and conquer strategy. The fundamental idea is very simple. So instead of analyzing the entire viewing area at once, so the viewing region is repeatedly divided into smaller rectangular section. That is what the working principle of area subdivision method. For each section, the algorithm determines whether the visibility is can be decided immediately. With visibility cannot be determined, so the section subdivides further into smaller regions. I'm repeating, for each section, the algorithm decides whether the visibility decided immediately. If the visibility cannot determine, so the section subdivided into further smaller regions. So this process continues recursively until the visibility becomes clear. So, so this approach reduces the unnecessary calculation by focusing only on complicated areas of the image. So take out this, it's entire view of the visible area. So apply the test whether the area is subdivided or not. If it is visible, if it is for each section, the algorithm decides whether it is visible or not. If it is not able to determine, section is going to be subdivided into smaller subsection. Okay, so at every level we have to apply test. Otherwise, we have to divide the image. Divide the visibility area into subdivisions, subsections. Okay, while doing the divisions, so the area is having some surface relationship with the uh, visible area, where we are having in the four kinds of surface: surrounding surface, overlapping surface, inside surface, and outside surface. Surrounding is the surface which is completely enclosed the area. So check out this image. So the area which is completely enclosing the visible area, that's what surrounding. Next one is overlapping surface. The test surface is partially inside and partially outside. So this gray area is a test area which is partially inside and or partially outside. And third one is inside surface. So our inside our testing area, some part is completely inside my testing area. And check out the last one is actually outside surface. So this is the gray screen is my surface, and this object is completely outside the surface. So the area surface relationships given here. Okay, so when we have to stop the subdivision, so we are taking the entire image, entire visible area into subdivisions and so on and so forth, right, recursively. So when I have to stop, so the conditions are given, all the surfaces are completely outside the specified area. In that case, we no need to subdivide. If some cases, if there is only one overlapping surface or only one inside surface, in that case, you can apply the background color, and then you can do the surface can be removed or scanned and converted. In some time, so there is a single surrounding surface but no overlapping or inside surface. In this case, the area is filled with the color and surrounding surface. Okay, so based on some condition, we can stop the subdivision. So the same thing is given here. Whether the surface is completely outside the area, we can stop it. And area has only one inside and overlapping and surrounding surface, that also possible. And the area is as one surrounding surface that obscures all the other surfaces within the area's boundary. So in that case, we can stop the subdivision. Okay, and so that is what the subdivision method, how it works. So the advantages side, the area subdivision method is it reduces the visibility calculations, and suitable for scenes for containing large empty regions, and is efficient for certain types of complex images. And coming to the drawback side, the recursive subdivision can become expensive, and performance decreases when many objects overlapping, and large number of subdivisions may be require highly detailed scenes. Okay, so that is what the drawbacks of the area subdivision method. Let's move on to the next algorithm, octree method. So octree method is extension of spatial subdivision technique into three dimension actually. So in the previous one, area subdivision, we are having two dimensional. So the same is implemented in the three dimensional view. That's what the octree method. So here we are having surfaces towards the front of the viewer, which is 0 1 2 3. Consider this 8 octets are there, nodes are there. So 0 1 2 3 are in front of the viewer, and 4 5 6 7 is going to be in the back side of the viewer. Okay, so when with the numbering method, the nodes are representing the octants 0 1 2 3 4 5 6 on the entire region we can represent in the 8 areas. Okay, so that is what the octree method. So let us see the working of the octree method. So the algorithm begin with the large cube representing the entire scene, and the cube is recursively divided into smaller cubes. For example, if you take the front view, so it is going to be taken like this. Each subdivision continues until the cube contains only one object, or cube becomes sufficiently small. So this results a hierarchy structure which is called as octree. Okay, so during the rendering, the system examines the only the relevant octants are instead of processing the entire scene. So this significantly improves the efficiency. So this is how the octree method is actually working. Okay, and coming to the advantages of the octree method, uh, it provides a efficient spatial organization similar to area subdivision method. It reduces the number of visibility comparisons because of division subdivisions. It accelerates the rendering complex scenes. So in 3D modeling, collision detection, virtual reality, game development, in all these area, this octree is efficiently actually supporting. Though we are having advantages, we are having some limitations. So limitations are needs additional pre-processing time for every image we are taking, and memory consumption also increases with the if you are submitting the high definition images or objects. Okay, so that is what the octree method. So moving on to the next method, ray casting method. So the ray casting visibility, it's determines whether the object is visible at each pixel. So it's a image based. So the basic idea is inspired by geometric optics. Instead of processing the object first, the algorithm start from the viewer's point of view. So from the viewer point of view, it is for every pixel on the screen, an imaginary ray is projected onto the screen. From the object, the imaginary line is going to be projected every pixel on the screen. So the object intersects the ray, the first becomes the visible object. So when we are projecting the from the scene to the object, which object is intersecting, that's going to be displayed onto the screen. So this technique is particularly effective for the scenes containing the curved surfaces such as the spheres. Let us move on to the working of ray casting. So at the step number one, we have to generate a viewing ray, imaginary line. Step number two, trace the ray onto the scene. And third step, we have to calculate the intersection between the ray and the objects. So as we saw seeing in the image, we have to project a line onto the object. So if it is intersect, so we have to find out the nearest intersection point. Okay, and display the color of the nearest visible surface. So that is the step number 5. So this process should be repeated for every pixel in the image. Okay, so the result is an accurate visibility result. Okay, When comparing with the depth buffer and raycasting method is actually pixels are processed first in raycasting, whereas in depth buffer, surfaces are processed first. Okay, in depth buffer method, depth value calculated for each pixel, whereas here, all the surfaces are intersected by the ray are examined. Okay, that is the raycasting method. Sometime you may confuse with the ray casting and the ray tracing. So ray casting is trace one ray per pixel. So you have to project a one ray per pixel, find the nearest intersection point that is going to be visible one. In ray tracing is you will be tracing multiple rays and simulate the reflections, refractions, produces the realistic lighting effect. That is different. Ray tracing is different. Ray casting is different. You can check out this one, ray casting and ray trace. So for lighting and all, reflection and all, ray tracing is very much useful. But whereas ray casting is only one single ray onto the object. So coming to the advantages part of the ray casting, so it provides, as I told already, it provides a accurate visibility decision and handle the curved surface, especially spheres, uh, clearly, and it also produces the realistic images suitable for the geometric scenes. So that is what about the ray casting method for visible surface reduction. In this session, we discussed the algorithm, area subdivision, octree, octree method, and the third one is ray casting method. Oh, thank you for watching. So next session we'll be discussing the rest of the three algorithms. Thank you all.